Hey everybody, the purpose of this video and the next couple are just to get you some solutions to the last three equations we looked at but didn't have time to finish in class today. So the first one of the three, I believe, if I've written this down right, yeah, is this guy right here. 3 over x equals 1/10. So the idea was, and I know a bunch of you are solving these different ways and that's totally cool, I got no problem with that. But the idea is, I was trying to kind of use one method for all equations that'll work across the board for all equations. And there is one that will work for all equations, and I think of it as the Lego method. Undoing any expression that's been done to x, back to x. So in other words, you want to start with the variable of interest, x, and you want to do things to it until it looks like this one, 3 over x. Because once you know how to get step by step from x to 3 over x, you'll know what to do in the reverse order to undo all that stuff. Okay? So you can kind of distance yourself from the ugliness of any equation and just go straight to this. So what you have to ask yourself is, getting from x to 3 over x, what's the first thing that happens? Now, because of order of operations in this particular problem, there are two things that happen to get from x to 3 over x. And it doesn't matter which one you do first because they both live on the same level of order of operations. I think what hangs most students up is the fact that x is in the denominator. So in other words, this guy right here, if you think about it, is really x over 1. I mean, anytime you see any number, 2 is the same as 2 over 1, 6 is the same as 6 over 1. Any integer or any whole number value without a denominator is the same thing as that number over 1. We just get used to not writing that. We don't write integers as fractions very often. So if you can view that as x over 1, you realize what you really need to have is you need to have x in the denominator. So what you want to do is you want to turn x into its reciprocal, which is something you learned many years ago, back in probably pre-algebra, maybe algebra class. So to get from this to this, all you've got to do is take the reciprocal. And that turns x over 1 into 1 over x. Piece of cake. And then, to get from 1 over x to 3 over x, you've just got to increase this 1 to a factor of 3. Well, again, it calls on your old mathematical skills, but to take this and make it this, you've essentially, if you will, you've added 1 over x to it twice more. But we don't, I mean, imagine if that was a 10, then you'd have 10 of those. It gets annoying to do that over and over again. So we invented multiplication to take care of that. So to get from here to here, you just multiply by 3. Multiply by 3. Boom. Done. You've gotten from x to 3 over x. You took the reciprocal, and then you multiplied by 3, and that got you right here. It's simple as that. Now, the reason why it doesn't matter which one you do first, you could have multiplied by 3 first and gotten 3x, and then taken the reciprocal of the 1 over x. But the trick with that is, you might try to take the reciprocal of the entire thing and get 1 over 3x, which is not what you're looking at here. So this gets us there beautifully. And now that you're there beautifully, you can now undo what's been done over here. If the last thing we did was multiply by 3, the first thing we're going to do on both sides of this equation is divide by 3. And judging from what I heard from you guys in class, most of you, instead of dividing by 3, were multiplying by 1/3, which is the same thing. And I think this is what most of you picked up from your previous math classes. When you do that, the 3's divide off, leave 1's behind, and this guy over here turns into 1/30th. And this guy is 1 over x. Notice how this looks just like this? That's because you went backwards. And you're going to go backwards once more. You're going to take the reciprocals of both sides. Take the reciprocals of both sides, and you end up with x over 1, or x equals 30 over 1, or 30, and my friends, you are finished. You can always check it to make sure it works, but that's golden. You're absolutely golden right now. One cautionary, I guess, word about this. When you took the reciprocals of both sides, because this is a proportion, that works beautifully. And in most cases, they always will be proportions. I'll mention in the next video about a case where it doesn't look like a proportion, but you can make it be one. So we'll deal with that momentarily. But there you go. We'll see you in the next one.